Hello guys, and welcome to another video. So in this video, as you can see on the title, we'll be looking at questions that involve work, energy and power. So here we have a question, and we are told that an ice skater of mass 53 kg moves on a frictionless surface AB with a velocity of 6 meters per second and then slides up a rough inclined surface BC until coming to a stop at point C, 1.5 meters above the horizontal. The angle between the incline and the horizontal is theta. Then 5.1 says, state the work energy theorem in words. So if we state the work energy theorem in words, we must firstly recall the formula. And the formula for the work energy theorem is W net is equal to delta EK, or sometimes they'll use delta K. So this is where we are going to get the work energy theorem from. So we will say that work energy theorem states that the net work done. Okay, so this is it, guys. We'll say, using the formula, the net work done on an object is equal to the object's change in kinetic energy. That's all, guys. Once you write the formula, work net is equal to delta EK, you say that the net work done on an object is equal to the object's change in kinetic energy, and you'll get your 2 marks. Now let's move on to 5.2. 5.2 says, draw a labeled free body diagram showing all the forces acting on the skater at point C. So our skater moves from point A to B, and then when they get to point B, they now slide up this incline, or skate upwards this incline. Then they'll come to this position here, C. When they get here, that's where they come to a stop. But the problem is that because they are on an inclining surface, or an inclined surface, that means that gravity will actually be pulling this person downwards. Okay, and as much as they'll be here, gravity will want them to slide back downwards, and that means the direction of motion will be downwards. And I'm telling you this because we need to figure out where our friction is going towards in terms of the free body diagram. So if gravity is pulling this object or the skater downwards, where is friction going to act? Friction will act in the opposite direction, which is in this upward direction, or rather up the incline. Then we will have our force of gravity and our normal force, because remember, we said that we look at the marks to determine the number of forces that we are supposed to have on our object. So when we draw the free body diagram here for 5.2, we will have our dot first, and then we will have our force of friction. This will be our friction, and we will have our gravity. Because I'm not using a ruler, guys, my drawing will not really be too straight, and our normal force will look something like that. And that's how our free body diagram is supposed to look like. Okay, remember that when you're drawing a free body diagram for an object that's on an incline, the normal force has to be bent slightly so that it shows that the normal force is perpendicular to the surface. It shouldn't be in the same line as that of gravity. Okay, so that's what you must be aware of. All right, that's it for question 5.2. Now we move on to 5.3. 5.3 says, explain the term non-conservative force. So if we define non-conservative force, we will define it as the force in which the work done is dependent on the path taken. Okay, so it is the force for which the work done on an object is dependent on the path taken. That's how we'll state it. So this is your definition, guys. The term non-conservative force is the force in which the work done on an object is dependent on the path taken. All right, that's how you will get your 2 marks. Now let's move on to 5.4. 5.4 says, calculate the angle theta of the slope if the skater experiences a frictional force of 20 newtons while skating up the slope. So for us to answer this one, guys, this is what we have to firstly do. We go to this diagram of ours first and our statement. So when you read our statement, we see that the skater has a mass of 53 kgs. They move up a frictionless surface AB. So between point A and B, there's no friction there. And then their movement will be at a velocity of 6 meters per second. However, when they get to point B, they will come to a stop. So this means that, guys, for them now to, they are not coming to a stop. My bad, guys. When they get to point B now, that's when they go up the incline, right? And the incline is from point B to C. So this means that the velocity which the skater was traveling with from A to B will now become the initial velocity when this skater moves up the incline. This 6 meters per second will become the initial velocity. And then when they get to point C, what will be our velocity? Based on the fact that we are told that this person comes to a stop at point C, it means that the velocity at point C, which is the final velocity, will be equal to what? 0, right? That's going to be our final velocity. It's going to be equal to 0. So final velocity here will be 0 meters per second. And then another thing that we must look at is that we are given the height, which is 1.5. So this 1.5 here is our height, the 1.5 meters. We need something else here. We need BC in order for us to find theta, because we can look at this whole thing here, this shape, as our triangle, which is what it is. And on our triangle, we have the opposite side and we have this side, which is the hypotenuse side. But we cannot find the angle without having two known sides. So it means that the first step for us to solve this problem is to find this side BC, which is the hypotenuse. Okay, that's what we are going to do. But which formula then are we supposed to use when dealing with this problem? Well, we go back here to this statement. On this statement, they're telling us that we have to calculate theta if the skater experiences a frictional force. So the key here is us realizing that we've been given a frictional force, and a frictional force is what? It's a non-conservative force. So the formula then we'll use is this one. WNC is equal to delta EK plus delta EP. This is the formula that we'll use to find the work done on this object, or rather to find this theta. But why are we using this formula? It's because on this formula, if we expand it, if we expand this formula, can I just move these to the side? Let me put them here. So guys, if we expand our formula, we'll find the work done by the force of friction. That is the work done by the non-conservative force, which is friction. So we'll say F friction. Let me just write it this way. FF delta X cos theta is equal to, and then when we expand this side, we have half mv squared final minus half mv squared initial. Here we will not have enough space. Can I just move this? So this will be our initial plus mgh final minus mgh initial. Then from here we are going to substitute. Do we know our force of friction? Yes, we do. It's this 20 newtons. So we'll put it here, 20. Delta x. Delta x is our displacement, guys. And if you notice on this diagram, our displacement is from point B to C. That's when the skater goes up the incline. So this means that BC is our delta x. So we can even note it here that BC, we can maybe say BC is equal to actually our delta x. So our first step is to find that BC. So delta x is unknown in this case. Then we have cos. what is our theta in this case? Well, our theta has to be 180 because this work is being done by the force of friction. Thus, our theta will be 180 degrees. And then what is our final velocity? Well, our final velocity when the object gets to point C is going to be 0. We can substitute here, but because I don't have space, guys, I'm not going to substitute. So I'm just going to write 0 there. This is our kinetic energy. So when I substitute to find my final kinetic energy here, I would put 0 there for the velocity and I would get everything as 0. But when it comes to the initial velocity, remember what we said? We said when the object moves from point B to C, it means that it will move with an initial velocity of 6 meters per second. So when I substitute on the other part, I will have half in brackets the mass, which is 53 kg, multiplied by the initial velocity of 6 squared, right? And then I move on to the final velocity, the final potential energy. The final potential energy is when the object reaches point C. So that means there I'm going to have plus the mass, which is 53, multiplied by the G, which is 9,8, multiplied by the H, which is 1,5. And then what is my initial potential energy? My initial potential energy starts here. It's here when the object is still on the ground. And if the object is still on the ground, you will realize here that we do not have any height. And if we do not have any height, it means H is supposed to be 0. So if I substitute with 0 here and multiply everything here, I'm going to get 0. So that's what I'm going to write there. But I want you guys to substitute this when you actually solve the problem. I'm not doing that because of the space I don't have here. Okay. Then we move on. What are we going to have this side? This side, it means we have 20 times delta x times cos 180. And this should give me negative 20 delta x is equal to. On the other side, this is what I have. On the other side, I have all of this, what I'm highlighting in green. That's what I'm going to put on the calculator. Okay, what I've highlighted in green is what I'm going to put on my calculator. So on my calculator, guys, I'm going to say half. And then in brackets, we will have 53 multiplied by 6, which will be squared, plus this plus, because remember, we are putting these. Obviously, the 0 I'm ignoring because I'm not going to use it. But you can say 0 minus this plus this. So this is what we are adding. Plus 53 in brackets, 9,8 in brackets, and 1,5 in brackets, minus 0. So the answer we get is going to be negative. The answer we get is going to be negative 174,9, and then we divide by negative 20 on both sides because we are looking for delta x. And if I say negative 174,9 divided by negative 20, the value that I'm getting is, for delta x, it's 8,745 meters, right? Once I have this delta x now, what I'm going to do is finally now find my theta. How am I going to find my theta? Okay, guys, this is where I'm going to find my theta. I will look at what I have. I have the opposite side here. This is opposite. And I have my hypotenuse side, this side. BC, which is delta x, is my hypotenuse side. So that means I'm using trig ratios here. You know, SOHCAHTOA. That's what I'm going to use. SOHCAHTOA. So SOHCAHTOA. If we look at SOHCAHTOA, I have opposite and I have hypotenuse. So that means I must use what? The SO part, sine, which is equal to opposite over hypotenuse. So what I'll say is sine theta is equal to opposite over hypotenuse. Then from here I substitute, but because I'm looking for the angle, this is what I must then do. I'm erasing here, guys, and I'm hoping that if you want to write everything down, you will pause the video. So when I find my theta, I will say arc theta is equal to arcsine of what? Of opposite over hypotenuse, right? And then from here I'm going to substitute. I will have arcsine of -1, and then my opposite in this case is this side, the height, which is 1,5, divided by my hypotenuse. My hypotenuse is BC, and we found BC to be delta X, and BC was 8,745. So that's what I'm going to write here, 8,745. And then I'm going to put this on the calculator. What do? I say shift, and then I press sign, then I do my fraction to say 1,5 divided by 8,745. And this will be equal to, my theta will therefore be 9,88 degrees. And this is my answer, guys. Okay, so this is how you solve this problem. I hope you understood, and please guys, do make sure that you like the video, you share it as well, and if you have not subscribed yet, please do hit that subscribe button. Also, if you didn't understand anything, just rewind, play back the video, and take your time with making sure that you understand this stuff. I hope you enjoyed this one, and I'll see you on the next one. Goodbye.